glad that you are watching this lesson. I am teacher Katimbo Richard, teaching mathematics. Today I've come with a new topic known as operations on whole numbers, having completed the other, which was whole numbers. In operations on whole numbers, we shall majorly look at the four operations we have in mathematics, that is addition, subtraction, multiplication, and division of the same whole numbers. That's why we've got this topic written clearly as operations on whole numbers. That is in P5 term 1, which work will be found on page 50 up to page 54. That is 51 to 54 of your workbook, which I'm very sure you have or have obtained from school. If not, then you had better got yourself a copy so that you practice, because mathematics is all about practice, and that's when the perfection will be reached. So like I said, we are looking at operations on whole numbers in P5 term 1, and the key words to look at are sum, difference, product, and quotient, which are the technical words that summarize the addition, subtraction, multiplication, and division of numbers. So the question is, how does one then obtain sum? Sum is the result after adding two or more numbers. When you add two numbers and get out what's called the outcome, that said outcome is the sum. For example, one can be asked, find the sum of 2 and 3. One will be required to add 2 and 3, so the working is 2 plus 3, which is equal to 5. That 5 is the sum. So sum means the result after adding two or more numbers. As opposed to difference. What is difference? Difference is the result after subtracting two numbers. For example, the difference of 10 and 8 is 2. You say 10 minus 8 is equal to 2. So the 2, as a result of subtraction, is called the difference in mathematics. When we look at product, product is the result after multiplying two or more numbers. Like the product of 2 and 3 is 6. The working is 2 times 3 to obtain that 6. So 6 is the product. Then quotient is the result after dividing two numbers. The quotient means the result after dividing two numbers. For example, one can be asked for the quotient of 6 and 3. One gets 6 divided by 3 and gets a 2. That 2 is the quotient because it is the result after dividing those two numbers of 6 and 3. So these are some of the words you are going to look at in the topic called operations of numbers. Like I said, I've got four operations of addition, subtraction, multiplication, and division. And today we are looking at the addition and subtraction, which will be found on pages 51 up to 54 of your workbook, P5 first term. And now we are looking at the addition of numbers, which examples I want you to look at keenly and then answer that work. Now, example number 1 says add 253 plus 149. You are required to add 253 and 149. So in most cases, the examiner will order their question horizontally, that is across, like this one is. And then for you, you are going to order it downwards using the idea or place values like of ones, tens, and hundreds. Hence, write 253 plus 149, but order 9 under ones, 4 under tens, and 1 under hundreds, and then show the equal sign before you add. Now you go to add. 3 plus 9, you get 12. You write 2 and regroup 1. Regrouping is the same as what you already say, carry. So you regroup 1 to the tens place value, and now 1 plus 5, you get 6, and that's 6 plus 4, you get 10. The moment you get anything to do with the 10 and above, you write the digit under ones, like 10 has got 0 under ones, and regroup the 1 under tens. So write 0 and carry 1 for I've got 10 here, or regroup 1 on the hundreds place value, and now 1 plus 2, you get 3 plus 1, you get 4. So the answer is 402. Hence, when 253 and 149 are added, one gets 402. You must then show the examiner that you regrouped or carried if you use the layman's kind of language. So you must show these ones on top to show that you will not use a calculator or any other gadget to add, because the gadget will not show you that it actually grouped, but will just give you only 402. So the examiner sees or must see that you did it yourself, meaning mentally, without necessarily using any gadget like a calculator. So you get that 402, and then the examiner will award you the marks according to this number. That's the way we work out. Then look at example number 2 that tells you to add 52 plus 346 plus 13,354. You add 52 plus 346 plus 13,354. This is the way it's done. Remember to care about the place values. 52 has got only 2, that's ones and tens. Whereas 346 has got ones, tens, and hundreds. Then 354 has got the same ones, 13,354 has got ones, tens, hundreds, thousands, and 10,000s. So align them in that order, starting with the ones. As you continue, you find out that others don't have the upper corresponding numbers. You shouldn't fear, and never should you change the order. So 52 is the first here. Matches it has got 2 only. Then you go to 346. It goes beyond 52 by 1. Then 13,354 goes beyond 346 by 2 place values. And then you start your addition. You go 2 plus 6 is 8. And now 8 plus 4, you get 12. You write 2 and regroup 1 to the tens place value. And then add 1 plus 5, you get 6. That's 6 plus 4, you get 10. Now 10 plus 5, you get 15. Write that 5 and regroup 1 to the hundreds place value. Now 1 plus 3, you get 4 plus 3, you get 7. This time you write the entire 7, no regrouping. Then write the 3 down here as well as 1. So you have got an answer which is 13,752 from the addition of the entire work of the entire numbers. In that way, you will have got the answer and nothing else. So that's how we order majorly, use the place value knowledge, and then order the given numbers, that is vertically. So they will order them horizontally, that is across. For you are required to put them vertically, order them vertically according to their place values before the addition. Please note the place values are actually catered before any addition or subtraction of numbers is embarked on. Then look at example number 3. This time is wordy. You have a tendency of fearing wordy questions. Sometimes you baptize them to be wordy problems. They are not actually problems. They are wordy numbers, which when read, you will find out which operation to use. But if you don't read, then you will not know whether it is addition or subtraction. Let us see whether it is addition for dealing with it. In Iganga district, there are 624,710 males and 715,624 females. It reads again. In Iganga district, there are 624,710 males and 715,624 females. Then the question reads, what is the total population of this district? So by hearing the word total, you think about addition. To total up is to sum up, is to combine all the figures that are involved. So that combination gives rise to the addition operation as our choice. So we are going to use the plus sign of addition operation to get the total population. You get the males and females added together and get the number of people in the said Iganga district. So you write 624,720. So 710 the males plus the 715,624 females. So you add and then get the total population. Answer will be in people, meaning the unit will be people. Don't write about population. So we go add. Under ones we have 0 plus 4, you get 4. 1 plus 2, you get 3. 7 plus 6, you get 13. You write 3, regroup 1 to the next place value. That is 1 plus 4, you get 5, which 5 plus 5, you get 10. You write 0 and regroup 1. 1 plus 2, you will get 3 plus 1, you get 4. This time write the entire 4. Don't regroup or carry like you want to say. 6 plus 7, you get 13. Now this time, being that this is the last addition or last sum, then we shall write the entire 13 without regrouping because we don't have any other to add. So the answer as total population is 1,340,334 people that are actually in this Iganga district. But all in all, you must know the key word that brings the addition operation into existence as our suitable choice. The word is total. Another word can be the sum, and the other words, like you see the word altogether, that one calls for a combination, which combination suits the addition operation choice. So, but here, the word in total tells us to add. So, in such numbers, you look at the keywords that will help us to choose the appropriate operation. Like here, total brought about the addition. Then we go to example number 4 today. It says in Kachiri Primary School, there are 96,234 math books and 2,842 math books in Kachiri Primary School. There are 2 schools here. Then the question is, how many math books do the 2 schools have altogether? Now here, the key word is altogether. It calls for a combination, which combination suits the plus sign of addition operation. So we are going to add the 2 numbers here and then get a total, which is altogether. So you get 96,234 written here plus 2,842. And with the plus sign of addition, both will lead to math books. And then you add 4 plus 2 is 6, and 3 plus 4 is 7, 2 plus 8 is a 10. You write 0, regroup 1, the next place value. 1 plus 6, 1 gets 7, which 7 plus 2 gets 9. And then this 9 remains to be written down. Then in total, the 2 schools of Kachiri Primary School, as well as Kachindu Primary School, have got a total of 99,076 math books. Both belong to math, and that is how 1 we detect its addition. In number 3, the word total calls for addition, and this word altogether in number 4 called for that addition. Before we look at the subtraction of numbers in the same lesson, hence of God, subtraction of whole numbers, and here are the examples. Example number 1 today reads, subtract 4,782 and 1,250. So it's written across, that is horizontally. You order it vertically. Please take care about the place values. That place value knowledge was given to you in the previous lessons. If you don't know how to apply them, please go back and watch. You will see how the place values are arranged. Still look at ones, tens, hundreds, and then thousands as you align them in that vertical order. That is 4,782 minus 1,250. Unlike addition, in subtraction we shall look at what's called borrowing. In case the upper number is less than the down one, then one needs to borrow. And remember, at our level, we're still dealing with base 10. Whatever we borrow here, we shall take it as base 10, or it will be equal to 10, which 10 will help the number that you're actually helping to grow bigger before you subtract. Let's see whether we've got that element here. Now 2 minus 0, the fact being that 2 is greater, we subtract normal and get 2. 8 minus 5, 8 is greater, subtract normally, 8 minus 5 get 3. 7 minus 2, 7 is greater, subtract normal and get 5. And here 4 minus 1, 4 being greater, subtract normal and get 3. So this one did not call for any borrowing, and the answer is 3,532 for that particular. Let's see whether number 2 will necessitate borrowing. It tells you to subtract these two. That is 8,024 minus 1,796. Now let's see if that element will come. Still order them in place values of ones, tens, hundreds, and thousands. We've got 8,024 minus 1,796. Now we go 4 minus 6. Now 4 is less. There's a necessity for us to borrow. So we go to 2. 2 gives us 1, which 1 is equal to 10. It remains with 1. So 1 remains here. And now we bring the borrowed 10 to 4, where 4 plus 10 you get 14. Cancel out the 4 and replace it with 14. Now 14 minus 6, you get that 8. 14 minus 6, you get that 8. And now, remember we remained with the 1 here. Now 1 minus 9, we cannot take away 9 from 1. We borrow a 1 from this 0, which 0 doesn't have. And now we go to 8. 8 gives us 1 and remains with 7, which 1 is equal to 10. And now 10 plus 0 that was here, you will actually get a 10. Now borrow 1 from this 10 and remain with 9. And now go all the way to this 1. So 10 plus 1 you get 11. So we get that 1 plus 10 and get our 11. That's why I've got 11 here now. 11 minus 9 you get 2. And now add 9 remaining here. That's 9 minus 7 you get a 2. And 7 minus 1 you get a 6. So remain with 6,228 as an answer when you subtract normally. I'll repeat the subtraction. We've got 8,024 minus 1,796 as original numbers. Now, where 4 minus 6, you cannot subtract. So 4 must be helped. Remember, we're basing or dealing in base 10. And now we borrow from 2 and remain with 1. Which one was borrowed is equal to a 10. Now get 4 plus that 10, get 14. Replace the 4 with a 14, then solve normally. 14 minus 6 you get 8. Now remember, having borrowed 1 from 2, we remain with 1. Now 1 minus 9, there's a necessity to borrow again from 0, which 0 cannot give you anything. So 0 needs to be helped as well. We go to 8 and borrow 1 and remain with 7 and put it here. 1 plus 0, sorry, 10 plus 0, because what we borrow is called 10. 10 plus 0 get a 10, and the intention of borrowing was helping this one. We borrow 1 from 10 and remain with 9, and now we bring that 1, which is equivalent to 10, onto that one. That is 1 plus 10 get 11. Replace this one with 11, and now I've got 11 minus 9 as a 2, and 9 minus 7 you get a 2, and 7 minus 1 get a 6. Thereby remaining with an answer which is 6,228 for that particular number. Before we look at number 3, example number 3 says subtract 36 from 100. Subtract 36 from 100. This one needs to be read and understood. You are supposed to subtract 36 from 100, meaning you must care about the word from. Subtract from 100, meaning 100 minus 36. 100 minus 36. So like 10, you subtract 8 from 10. That's 10 minus 8. Subtract 3 from 4. That is 4 minus 3. Subtract 2 from 5. That is 5 minus 3. So get to understand, when you see the word from, you change the order of the setting. Subtract 36 from 100 means you start with 100 minus 36. So on top we shall have 100, then minus 36, and then put the equal sign and start subtracting. Remember the place values of ones, tens, and hundreds. So 100 has got 3 digits, and 36 has got only ones and tens place values. And now we go 0 minus 6. Possible after borrowing, we cannot borrow from 0, we go from to borrow from 1. 1 gives us that 1 remains with 0, and which one is equal to 10? So we write it here and get a 10. And now the intention was borrowing up to this 0. So we get that 10, we borrow again from 10 and remain with 9, and now we go to this 0. Now 0 plus 10, you get 10. And now we put away this 0 and replace it with 10 for normal subtraction. That is 10 minus 6, you get 4. And now remember we make 9 here. Now 9 minus 3, you get 6. And here we went with 0, which 0 is not allowed to lead any whole number. So the answer is 64 for this subtraction. Repeating, the question is subtract 36 from 100. That one, as I said before, means 136. So therefore, 100 will be written on top, then 36 down. So that is 100 minus 36. Now, 100 minus 36, we look at the ones place value. We have got 0 and 6. 0 minus 6, there's no way we can take away 6 from that 0. We go to a neighbor who is a 0, and 0 cannot lend us anything. So then we borrow to the next neighbor who has 1, and now we borrow that 1 and remain with 0. And remember, this neighbor did not have anything. We bring that 10 onto 0, where 10 plus 0 or 0 plus 10 you get 10, and the intention was borrowing up to this 0. So we borrow a 1 from this 10 and remain with 9, and now we bring that 1 in terms of 10. That is 0 plus 10 you get 10. Replace this 0 with a 10 and start your subtraction normally. That is 10 minus 6, you get that 4, and this 9 minus 3, you get a 6. Remember, this side will remain with a 0, which 0 is not allowed to be written as beginning kind of digit for a whole or a whole number. So remain with 64 as the answer for that particular number. Then go to number 4, which tells us to take away. Take away 91 from 230. To take away is to subtract. So it's the same as subtract 91 from 230. So this question has got a language competence which is take away as opposed to direct subtract or the word subtract. So but they mean the same. Subtract this 91 from 230. So still look at the word from. The word or the figure that's led by the word from is the one we start with. So subtract or take away 91 from 230 is the same as 230 minus 91. So 230 will be written on top of 91 and put a minus sign of subtraction and start our subtraction. So now 0 minus 1, you see it is only possible after borrowing from 3. We remain with 2. And now we bring our borrowed one, which is equal to the base 10. And now we get 0 plus 10. We get a 10. So replace our 0 with a 10. And now I've got a 10 minus 1, which is a 9. And remember, we remain with the 2 here. 2 minus 9. Again, we borrow from 2, remain with 1. And which 1 we have borrowed is equal to 10. And now 10 plus 2 get 12. Now I've got a 12. 12 minus 9, you will get a 3. And remember here we get the 1, which is written down. So the final answer is 139. 139. When we take away 91 from 230, we get 131 that remains. That's how we use that borrowing language to answer such questions that call for the comprehension, meaning you read and understand to know which one is supposed to be put on top. Always care about the word from, where from is, or that word that's figure that's preceded with from, or a figure which is led by the word from, like C from 100 is the one you put on top. From 230, put it on top. And then 91 goes down. We shall then look at example number 5 today and see what it brings us. It reads, reduce 3,000 books by 143 books. Reduce 3,000 books by 143 books. Here the key word is reduce. To reduce is to take away or to subtract. Now, by telling you to reduce, the best option is the subtraction operation. So it's the same as take away 143 books from 3,000 books. So thereby writing 3,000 books on top minus 143 books. Remember to write the word books before you start. And again, remember to order them in the place values of ones, tens, hundreds, and then thousands. And now we start subtracting, beginning with the ones place value. Under ones is a 0. So I've got 0 minus 3, meaning there's a necessity to borrow from the neighbor. The neighbor has got 0 as well. We go to the next neighbor under hundreds. He has got 0 also. He cannot lend us anything. Then the best option borrowing here is 3. So remember, as we borrow, the neighbors that had zeros must also first share, and then they are supposed to lend us also. So we go, we borrow from 3, remain with the 2. And remember, the 1 we borrow is equivalent to 10, which 10 plus 0 is equal to 10. And then we borrow from 10, remain with 9. And that 1 again is equal to 10. That 10 plus 0 get a 10. Still borrow to make the intended borrowing. So remain with a 9. When we borrow 1 from this 10, we remain with 9 and then bring that 10 to 0 and get a 10. Now we subtract normally. That's a 10 minus 3 is equal to 7. Remember, we remain with 9 after borrowing. That's 9 minus 4. We remain with 5. And now 9 minus 1, you get 8. And then this 2 goes down to get the reduced number of books as 2,857 books. Remember, wherever you're told to reduce, you get a reduced figure. You see that the answer we got at last is actually less than 3,000. Hence, we shall have reduced 3,000 books by 143 such books to get 2,857 books finally. So look at example number 6, which reads, find the difference between 1,479 and 1,749. The question reads, find the difference between 1,479 and 1,749. So you will find out the major word or keyword to our choice of the operation, which is difference. Remember I said at the beginning of this lesson that difference is the outcome after subtracting two numbers. And now here they are. That is 1,479 and 1,749. Here you must look at the two keenly and see which one is greater. Of course, 1,749 is greater than 1,479. Therefore, the greater is put on top. That is 1,749 minus 1,479. Sorry, 79. And now you subtract normally. Under ones, tens, hundreds, and thousands. So I've got 9 minus 9, which is 0. And now 4 minus 7. 4 minus 7. 4 minus 7. Get to know that 4 being less, it necessitates borrowing from 7. When you borrow 1 from 7, you remain with 6. Which one you have borrowed is equal to 10. Now 10 plus 4, you get 14. Now 14 minus 7, you get 7. And then remember, remain with 6 after borrowing. Now 6 minus 4, you get 2. And 1 minus 1 is equal to 0. Which 0 must never leave any whole number. So thereby remaining with 270 as the answer. But now, which word must you look at keenly? The word is difference, which means the result after subtracting two numbers, which we have done successfully to get 270. Be careful with the keywords that will give rise to the operation before we look at the last example today, which is a word number, the one we call a word problem. It reads, the population of Uganda in 1980 was 12,350,500. If 7,254,619 of them were males, how many females were there? The question reads again, the population of Uganda in 1980 was 12,350,500. If 7,254,619 of them were males, then how many females were there? You will learn that this was the total population, which was 12,350,500 then. And now that time, the male population was 7,254,619. That was the male population. Then asking for the female population. Remember, among the population, the males are those men and boys, and the females are those girls and women. Now, boys and men combined were 7,254,619. Now they're asking for girls and women that time. So what do? You get a total population minus the male population. Total population minus the male population. You are going to get a female population. So meaning you're going to opt for the subtraction operation. That's 12,350,500 minus 7,254,619. Then we remain with female population. And again, you order them very well, under ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, and 10 millions. And now we start to subtract under ones. Now we've got 0 minus 9. It's only possible after borrowing. We can borrow from 0, we go to 5, and borrow 1, which is equal to 10. So when you borrow 1 from 5, remain with 4. Bring that 10 plus 0, you get a 10. Borrow 1 from 10, remain with 9. Bring that 10 to 0 and get 10. Now start subtracting normally. That is 10 is 10. Minus 9, remain with 1. And now 9 minus 1, you get 8. And now 4 minus 6. It necessitates borrowing again from 0. You can never. Then go to 5, borrow 1, remain with 4, and bring it to 0 and get 10. 10, remember what you have borrowed is called 10, so 10 plus 0 gets 0. And now we go borrow from 10 and remain with 9. Bring that 10 onto 4. 10 plus 4, you get 14. Now 14 minus 6, you get 8. Remember, we remain with 9 here. 9 minus 4, you get 5. And now remember, we remain with 4 here, which 4 minus 5 is only possible after borrowing. We borrow from 3 and remain with 2. And remember, what we have borrowed is equal to 10. 10 plus 4, you get 14. Now 14 minus 5, you get 9. And now 2 minus 2 is a 0. And now we've got our 12. 12 minus 9, you get 5. So how many females were there in 1990? So the females were 5,095,881. There were 5 million, if you want to put a comma here, read well, that is 5,095,881 females that time in Uganda. All in all, it's knowledge of choice of the operation to be used. If you have a little population and they give you males, then the females will be got by subtraction. Likewise, if you have got a class of 60, of whom 50 are males, and they ask you for the they ask you for the number of girls, you subtract. You get 60 minus 50, you get the girls as 10. So that's the story. You can say the number of pupils in the class is 60, of whom the boys are 60. How many girls are there? So whom I said the boys are 50. How many girls are there? You say 60 pupils minus the boys who are 50, you get 10 girls. In that way, you will be able to answer. So choice of the operation is the one that's very important. I am teacher Katimbo. Richard has taught you that. For more information about the same, please call teacher Katimbo on 0776 251655. Otherwise, stay safe.